Hello everyone, I hope you are all well and healthy. Still with me Party Roseate. In this session I will explain how to start heating up until the kiln is ready to operate. This is a display monitor in a simulation program to operate the kiln system, with a clinker production capacity of 5,500 tons per day. In the previous session we have made preparations to start heating up by starting the preheater ID fan, transporting clinker, and starting cooling fan grate 1. In this explanation we use a simulation speed of 10 cycles per second or 1/10 times the normal time. Before starting the firing of the main burner, it is recommended that the draft behind the preheater be given an automatic position with a setting of -1.5 to -2.5 millibar, so that when we add damper openings or increase the rotational speed of the SPID fan, the rotational speed of the kiln filter ID fan will increase automatically. Then the kiln head draft is also given an automatic position with a setting of -0.2 to -0.4 millibar, so that when we add cooling air from the cooler, the cooler ID fan damper will increase automatically, and adjust to the kiln head draft setting. Previously we have prepared a heating up procedure curve, and this is an example of heating up for 12 hours. The guide for temperature rise is the temperature at the kiln inlet. The requirements for starting the feeding kiln are around 900 degrees Celsius. As a guide for raising the temperature in the kiln's sintering zone and in the kiln inlet. This 12-hour heating up procedure is usually used to start the kiln without replacing the refractory brick. Let's start the main burner. We start the group, and here there are two buttons. This is the shutoff valve button must be open. Then this is the regulating valve to regulate oil consumption. We set the first time to firing 1000 liters per hour. After entering the fuel oil in the main burner, then we observe the parameters on the kiln display, especially O2, CO, temperature in the sintering zone, and in the kiln inlet. We observe here, the temperature in the sintering zone should be higher than the temperature in the kiln inlet. But currently the temperature is higher in the kiln inlet. This means that the pull of the preheater ID fan is too fast. Let's try to reduce it using the addition of air from the cooler. We add 10% each and we observe whether the heating temperature can last in the kiln and not be pulled quickly to the preheater system. We return to the kiln display again. The temperature in the kiln inlet is 181 degrees Celsius, and the temperature in the sintering zone has started to rise. Now that we have fired for an hour, we will add fuel, but first we must add O2 by adding the ID fan damper opening, so that the CO does not rise when we add fuel. We add fuel oil 300 liters per hour, from 1000 to 1300. Then we observe the temperature changes in the kiln system. With the addition of 300 liters of oil per hour, we observe the increase in temperature in the kiln. In this heating up kiln, 1 hour after firing the auxiliary drive must be run or the kiln must be rotated, so that the temperature in the radial direction is evenly distributed. We start the auxiliary drive. This auxiliary drive can run if the lubrication is run first. We start the lubrication. The process is in progress. After lubrication is running, the auxiliary drive will automatically running. After the kiln is rotated with the auxiliary drive, we observe again the process parameters in the kiln system. To do this heating up should not be too fast, must be done slowly or naturally. The temperature from inside the kiln rises to the preheater slowly. Due to conduction heat, radiant heat, the heat from the high kiln to the top preheater is low. The purpose of this heating up kiln is to heat the combustion chamber in the kiln to a predetermined temperature, so it should not be pulled too quickly into the preheater system. Heating up has been running for about 2 hours, and the temperature in the sintering zone is almost the same as that in the kiln inlet. The temperature in the sintering zone should be higher, because at the first start, the air inlet to the preheater system was too fast, so that a lot of temperature was pulled into the kiln inlet. Now the temperature in the sintering zone has started to rise faster, compared to the temperature in the kiln inlet. We add more fuel consumption, before we increase the opening of the preheater ID fan damper first, from 30% to 40% for line 1 and line 2. Then we increase the use of fuel oil from 1300 to 1600 liters per hour. After increasing the fuel consumption, then we observe the temperature changes in the sintering zone, kiln inlet, and all temperatures inside the cyclone up to the top of the cyclone preheater. O2 and CO are still safe. O2 is still above 5% and CO is still 0%. All conditions are still safe and under control. Then at the 6th hour we will mix it with coal fuel. And for mixing coal, the temperature in the sintering zone should be around 550 degrees Celsius, so that the coal can burn completely. The current kiln inlet temperature is 290 degrees Celsius and the sintering zone is 360 degrees Celsius. We will increase the oil consumption from 1600 liters to 1900 liters per hour. Then we observe the temperature and especially the O2 and CO, lest any CO rises in the system. This CO has started to exist. It's already the 5th hour, the temperature in the kiln inlet is 370 degrees Celsius and the sintering zone temperature is 380 degrees Celsius. At the top of the preheater the temperature is 44 degrees Celsius line 1 and 45 degrees Celsius line 2. We can increase the fuel oil, because O2 is low, then we have to increase the opening of the ID fan preheater damper from 40% to 50% for line 1 and line 2. Then we increase the use of fuel oil from 1900 liters to 2200 liters per hour. Then at the 6th hour, we will mix fuel oil and coal. The method of mixing with coal is the calorific value of oil 8,650 kilocalories per kilogram divided by the calorific value of coal, for example 5,000 kilocalories per kilogram, equal to 1.73, meaning to replace 300 liters of oil with coal, around 519 kilograms of coal. Because the temperature in the kiln inlet has reached 560 degrees Celsius and the sintering zone has reached 760 degrees Celsius, we will mix oil with coal. And before that, we first increase the direct damper opening to 100% line 1 and line 2, then we increase the ID fan speed from 5% for line 1 and line 2. Because we will reduce the use of oil and mixing with coal. We reduce the use of oil from 2200 liters to 2000 liters or we just set it to 2000 liters per hour. Then for the first use of coal we use 1.5 tons per hour. We return to the display kiln. The cyclone's top temperature rises rapidly, because this damper ID fan cooler 0%, then we add the use of cooling air in cooling fans. We increase the air consumption of the cooling fan, each of which is increased by 10% for cooling fans 1, 2, and 3. Then we observe, the ID fan cooler damper has started to open and the kiln hood draft is minus 0.2 millibars. I corrected that earlier, the preheater ID fan speed should not have been increased and the first coal consumption was 1 ton. Because we only reduced oil by 200 liters per hour. So that the temperature is not attracted to the top preheater and is maintained in the kiln's sintering zone and in the kiln inlet. The temperature in the kiln inlet is still 566 degrees and the sintering zone is still 778 degrees Celsius, it should be around 800 degrees Celsius. We will increase the use of coal fuel again, to 2 tons per hour. Then we observe the temperature in the kiln inlet and sintering zone slowly rises, and O2 is still sufficient. In this 8th hour we use 2 tons of coal per hour and 2,000 liters of oil per hour. Meanwhile, the temperature in the sintering zone is 820 degrees Celsius and the temperature in the kiln inlet is 610 degrees Celsius. We increase another half a ton of coal consumption in the main burner, to 2.5 tons per hour. Because O2 is still sufficient, so when increasing the use of coal fuel it does not increase the preheater ID fan speed. O2 in the top preheater is still around 5% and at the kiln inlet it is still 5%. We observe the temperature of the whole system, and slowly the temperature rises, and the temperature of the kiln shell has started to rise. If the kiln shell temperature rises to 300 degrees Celsius, then the main drive kiln must be run. Because the temperature rises quickly, all transportation in the cooler system must be started. We start all cooling fans and grate drives, so after feeding later, we just need to add damper openings for each cooling fan. We start the grate 2 cooling fan, then we also start the grate 3 cooling fan, immediately at the same time we start the grate drive. Next we see on the cooler display, after the grate drive is running, we have to set the grate speed. We set the grate 3 speed to 50%. The grate 2 speed 40% and the grate 1 speed setting a minimum of 20%. Then for the cooling fan, we open the damper for each cooling fan by 10% for grate 2 and grate 3. After that, we'll see if the cooler ID fan damper opening and the kiln hood draft are too high or not. The cooler ID fan damper opening is quite low and the kiln hood draft is 0.2 millibar. Return to the main display to monitor the condition of heating up. We see here the temperature of the sintering zone is 880 degrees Celsius, and the kiln inlet temperature is 660 degrees Celsius. Then we increase the use of coal fuel again, to 3 tons per hour. Then we observe the temperature, at this 9th hour, the temperature according to the heating up curve is around 715 degrees Celsius. Then the use of coal fuel is 3 tons, and the fuel oil consumption is 2,000 liters per hour. We increase again for the use of coal fuel at the 10th hour, we increase it to 3.5 tons per hour. We observe the process, then here O2 is low and CO starts to rise, so we increase the preheater ID fan speed from 10% to 15% for line 1 and line 2. So that CO does not continue to rise, both in the top preheater and in the kiln inlet. CO has started to tend to fall and O2 in the preheater has started to rise above 4%, and also at the kiln inlet. So, when we are ready to feed, we just need to increase the fuel and start the kiln main drive. The temperature rose a bit slowly, and the kiln shell temperature was already above 230 degrees Celsius. Currently, we have opened the preheater ID fan damper to 100%, and the ID fan speed is already 15%. Then this cooler ID fan damper opening is still low, then we have to increase the cooling fan damper opening from cooler. We increase the damper opening of the Grade 1 cooling fan from 30% to 40% each, in order to help the combustion air in the kiln, because we are already using coal as fuel. Then we look at the others again. This one is still yellow in the Grade 3 cooling fan. It turned out that the motor cooling fan couldn't start, because the damper was still 10% open. We close the damper first, then we start the cooling fan for Grade 3. There is a timeout. We reset first and then start the group. Then we observe whether the cooling fan can start or not. Okay, now it has started. Then we open the damper 10%, the same as other cooling fans. Then we move the display to the main monitor. We observe all the parameters in the preheater and in the kiln. The temperature of the sintering zone is already 1000 degrees Celsius, and the temperature in the kiln inlet is 750 degrees Celsius, and the O2 is still above 6%. Because the preheater's top temperature is already high enough, so to add fuel to the main burner kiln, we don't increase the preheater ID fan speed anymore. But we can still add fuel, from 3.5 tons to 4 tons per hour. At the 10th hour, the kiln inlet temperature is 770 degrees Celsius, then 1 hour before starting feeding, the kiln main drive must be run. At the 11th hour of the kiln main drive we start. The kiln main drive can only start if the auxiliary drive is stopped. We have to stop the auxiliary drive and automatically start the main drive motor. Then we set the kiln main drive speed, 0.6 RPM minimum speed. Kiln shell temperature is 256 degrees Celsius, and this kiln migration is 15 mm. For normal kiln operation the migration is usually 10 to 15 mm. Then the kiln inlet temperature is above 800 degrees Celsius. And the temperature at the top of the preheater is very high. This must be attempted to decrease by reducing the draft behind the preheater setting from -2.5 bar to -1.5 bar. We can prove that by reducing the draft behind the preheater ID fan, the top temperature of the preheater decreases slightly. Because all control parameters and all temperatures in the preheater, sintering zone temperature, kiln inlet temperature, and kiln main drive have been run, then the kiln is ready to start feeding. That was the explanation on how to do the kiln preheating according to the procedure. For the next session we will explain how to start up the kiln operation. Thank you for watching this video. Hopefully it's useful, and don't forget to subscribe, like, comment and share. And see you in the next video.